Here we have a very short but very punchy organic chemistry exam question from the OCR specification, and it is a level of response. So whilst this might look like a very short description of what you need to do, this question does carry 6 marks, and your layout for this is going to be incredibly important. We've been told to describe the oxidation reactions of butan-1-ol forming an aldehyde and a carboxylic acid, so that's 2 separate reactions. And we need to explain using a diagram how the aldehyde can be produced in the lab by controlling the reaction conditions. So here, this is entirely instruction-based, isn't it? There's nothing here that's really setting the scene for this. You are just being told to provide the details of 2 different reactions and then an apparatus diagram. So let's have a look at my full mark scheme for this one and how I would choose to lay out my answer. So I'm going to split my answer up into 2 clear sections. I'm going to do the reactions first, one at a time, nice and clearly, and then I'm going to move into the diagram after that. So I've got my 2 different reactions here. Let's get them all on one screen. That's lovely there. I've got my butan-1-ol being oxidized to form an aldehyde, and I've got my butan-1-ol being oxidized to form butanoic acid. Those are the 2 different options I've got here. Now for both of them, I use the same reagent. It's acidified potassium dichromate 6 each time. Now, because this is a level of response question and I don't want to take any chances, I provide the name using the systematic naming, including the Roman numeral just there, and I also include the formula. And this is my oxidizing agent, but the difference, even though I'm using the same oxidizing agent in these 2 reactions, is the fact that to make the aldehyde, I'm going to be heating under a distillation, and for the carboxylic acid product, I'm going to be heating under reflux. Please make sure you don't just say that you use a distillation or just a reflux. You've got to make it clear that these processes involve heat, and the mark schemes have been picky about that in previous years. Here, I've then provided my reaction equations. As you can see here, I've got them using skeletal formula. You could use other types of formula for this. You could use structural, but I think that's a bit of a gamble, personally, especially when it comes to the aldehyde. You could use displayed formula, but what an absolute ache that would be in terms of time. You're going to run out of time in the exam if you do everything in displayed formula. I think here, skeletal formula, if you rehearse it and include it in your exam questions, is not only the most time-efficient way of representing your organic molecules, but it's also one of the most detailed way. And so I would strongly advise you to incorporate skeletal formula wherever possible. I should also make a point that it is incredibly risky to go with molecular formula in your organic chemistry exam, as a significant proportion of the exam questions will not allow molecular formula, although occasionally they do instruct you to use it, especially in something like a combustion, where it doesn't really matter what the structure of the organic compound is. Here, I've gone for skeletal. So for the butanoic acid reaction, just down here, the only difference here in these reaction equations, if we're looking for things that change from one to the other, is I go from 1 mole of the oxidizing agent to 2, and then down here I've got my 2 different products. You'll notice that the amount of water created in each process is actually the same. I also have elected to name the molecules all the way through here, again because this is a level of response question and I would want to make sure I'm providing enough of that additional detail. And so I want to make sure alongside each structure I provided that name. For the diagram of the apparatus, as I've already mentioned, in order to make the aldehyde I need to use a distillation. This is how I would draw a distillation in the exam, and you can see all of the labels here that I've included, with the exception of the thermometer, because that actually isn't included as a label in most mark schemes. These are all labels that you need to have as an absolute minimum. I've got my pear-shaped flask, although you could go for a round bottom flask. I've got heat, don't forget about that. The condenser, and then the direction of water flow here is really crucial. So please be very careful that you show water going in at the lower level and coming out at the upper level whenever you draw a condenser. I've also then got a little conical flash just here where my fraction will be collected in this process, which would be my aldehyde in this case. Thank you so much for watching this tutorial. I really hope it has made a difference, but before you go, I do need some help. Please leave this video a like before you go, because it really does help support my channel and let YouTube know I still exist. There's loads of good stuff around the screen now and links to my other video content in the description down below, so make sure you check that out before you head off. Until next time though everybody, happy revising.